All right, this is one of my favorite objectives to teach. 6.1 is that you will be able to find the area under a function using exact areas. The procedural fluency level is going to be when I'm giving you the areas, like exactly what they are. The application level is when you need to find them yourself. So, the process of finding the area between a function and the x-axis is called an integral. This is the symbol for integral. Um, It is, well, we'll talk about more about it later, but it's like a vertical line with a little bit of curve at the top and the bottom. An integral in terms of a graph, which is what we're talking about today, means finding an area. At the top and bottom, they tell you where this should start and end on the graph. So the bottom will always give you the starting point, and the top will always give you the ending. And then it always, of course, has to tell you which function. I'm only going to give you one function at a time, so this won't be super interesting, but it does need to tell you what you're finding the integral of. So the integral of f of x from a to b. The dx at the end is reference to which variable we're talking about. Like it could be dt or ds or d whatever. For today, don't worry about it. It's always going to be x for a little while. The last couple of lines I'm gonna say while looking at the next picture. So what we have here is an actual image of this. When you're looking at this, you see areas like 19 and 4 and 18. Those are positive areas. The 9, the 11, the 5, these are negative areas. And then one more thing that's important here. When you're taking an integral going forward, so from left to right, everything is what I just explained. So 19 is positive, 9 is negative. But that would be reversed if you're going backwards. You're going to see that in part C when we do that in a second. So A asks for the integral from e to f in this function. Well, here's e, here's f. Integral means the area from e to f. Well, it's 18. That's all there is to it. Part B asks for the interval or the integral from 0 to b. So 0 is here and b is here. And you notice there's more than one area section that's been shown. We have a positive 19 and we also have a negative 9. So the area from 0 to b is positive 19 minus 9. So this is 10. And that's it. I could have asked for more or less. If we went a little bit farther, it would have been plus 4, then minus 11, minus 5, plus 18, and so on. The last one, I can see it's a little cut off by the video. Apologies for that. The last one is the integral from d to b. So here's the example of what I'm talking about. Here's d, and it's going backwards towards b, which is right here. When you go backwards, all the positives and negatives are reversed. So for part C, that 11 isn't negative if you're going backwards, it's positive 11. And then that 4 isn't positive, it's negative. So this is 11 minus 4, which is 7. Just by coincidence, all of these three came out positive, but you are going to have some examples soon where they are not.